Let's begin our discussion of composition of functions with a particular example. Two functions may be connected by the fact that the output of one is the input of the other. So for example, suppose I want to find the cost in dollars to paint a room of A area square feet. We need to know, right, the number of gallons of paint required. So let's suppose we know 1 gallon covers 250 square feet. Well, if we knew the area of the room, what we would then just do is take A, the area, and divide by 250 square feet. And that would tell us the number of paint cans that we would need, number of gallons we would need to paint the room. If we then knew that the paint was $30.50 a gallon, we could actually then get the cost by just taking the 30.50 multiplied by the number of gallons we need. If we wanted to do this all in one step, we could actually substitute in our information about n being f at a and our g at n in order to find the cost as a function of the area. So let's take a look at this in a little more detail. So what we know is the cost is going to be 30.5 times n, right? $30.50 multiplied by the number of cans. This equation is going to give us cost as a function of n. But remember, we don't want cost as a function of n, we want cost as a function of area. So what we need to do is rewrite the n in a way that doesn't include the letter n, but instead includes the letter a. So what we're going to do is we're going to remember that n is the area divided by 250. So now we put these two equations together. We know that c equals 30.5 times n, but since n is a over 250, we can take out the n and put in its place a over 250. And so we get 30.5 multiplied by a divided by 250. If I do a little arithmetic with my calculator, 30.5 over 250, I end up getting 0.122, and so c becomes 0.122a. It didn't necessarily look like this for those of you who remember doing composition, but what we actually have done here is the composition of two functions.